class, today we're going to be factoring special products today, which is our notes for 9-7. Okay, there's two patterns I'll be going over with you today. It's called the difference of two squares pattern and the perfect square trinomial pattern. They both are ways to factor special binomial products. Okay, so the first one we're going to go over first of all is called the difference of two squares pattern. Hence the name, because we're going to be taking this, obviously means difference because it's subtraction. So the difference of two perfect squares. And there's a way that you're going to remember to do this. So what we're going to do is we're going to take the difference of two perfect squares and factor those into two binomials. Obviously, in order for us to get a negative when multiplied, our signs have to be opposite signs. So therefore, we're going to put a plus and a minus. So always opposite signs. Whenever we're doing the difference of two squares, we always know we're going to get opposite signs when we factor those into two binomials. And all you do is take the square root of a squared, which is a, so that goes here and here, and the square root of b squared, which is b, goes here and here. So when we factor the difference of two perfect squares, we're going to have one positive, one negative, and all we're going to do is to take the square root of each of those terms. And that's how we get the two binomials, this binomial factored into these two binomials. So let's go ahead and now do an example from this topic. Let's call this example 1. Okay, we're going to factor. Let's take y squared minus 81. Okay, so if we look at this, does this fit the difference of two squares pattern? It does, because obviously it's subtraction, so it's a difference of two perfect squares. So we can use this method to do it. So we're going to go ahead and factor this into two binomials. Signs are going to be opposite signs. Opposite signs. And then all we do is take the square root of the first term, which is y, because y times y is y squared, so the square root of y squared is y. So the first term of each of our binomials is y. And then you take the square root of 81. Well, the square root of 81 is 9, so therefore 9 goes here and 9 goes here. Now we can check this using our FOIL method or our table method. And from the sounds of our class, most of you like the table method. So let's go ahead and check this and see if it works. So we're going to go y and 9, y and negative 9. Y times y is y squared. Y times a negative 9 is negative 9y. 9 times y is 9y. 9 times a negative 9 is negative 81. Highest degree, like terms. Now look what happens when we take a 9y plus a negative 9y. Those are going to cancel out our middle term. And then obviously we bring down our minus 81. If you notice, we got, by foiling this and checking if we got it right, we are correct. And the reason why is because we have opposite signs, and that canceled out that middle term, and we're left with our y squared minus 81. So y squared minus 81 is factored into y plus 9 times y minus 9. The key being opposite signs. That's the key. So let's put up here on our notes. Remember, it's going to be opposite signs. Whenever it's the difference of two squares, you're always going to have opposite signs, not same signs. Okay, let's do another one of these. Okay, let's do it a little harder here. This will be example 2. Okay, this one, let's say we want to factor. Let's factor 64 c squared minus 16. Okay, we still ask ourselves, is this the difference of two perfect squares? Can we use this pattern here? And yes, it is. Difference, 64c squared is a perfect square, as is 16. So therefore, we can factor it in this fashion. We know we're going to have opposite signs. So we're going to go ahead and put our two parentheses for our two binomials. And then obviously because it's the difference, we know we're going to have opposite signs. Okay? And then we just go ahead and take the square root of 64c squared, which is 8c. So we put 8c here, 8c here. Obviously 8c times 8c is 64c squared. Okay, and then we just take the square root of 16. The square root of 16 is 4. So that's why we get AC plus 4 times AC minus 4. If we were to FOIL this to check it, let's use FOIL this time to check it. First terms, 8c times 8c is 64c squared. Outside terms, 8c times a negative 4 is negative 32c inside terms, 4 times 8c is positive 32c, and then the last two terms is negative 16. Remember, whenever we use FOIL, the outside and the inside terms are always our like terms. And if you notice, if we add these two, we're going to end up canceling out the middle term. Now we're left with 64 c squared minus 16, which is what we started with. So we did factor this correctly. So this is our answer, 8c plus 4 times 8c minus 4. So that's how we factor the difference of two perfect squares. Now they are going to move on from there and ask you to solve those. So let's say that we have, for example, 3. Let's say we're just going to solve one like this.